So this is the C&I track on lighting innovations. I think we're going to have a pretty good pairing of interesting discussion here from Ken Latal and Brian DeLuca, both from ICF, Ken, and TRC, Brian. So I'm going to let them have at it and start with Ken.
Okay. Thank you. Thanks, Dean. Okay, so now we're going to talk about the fun stuff. We're going to get into some of the lighting innovations and how all of this actually applies to the various different programs that are out there. Wanted to get into some details. Technically, we called this recent advances in best practices in commercial lighting and controls. But the one thing is that we probably could have added to this title, except we didn't have any more room, was that we also wanted to talk to you about the lighting market, what's actually happening out there right now as far as, you know, the kind of technologies that are in place and what we need to do with them. For those of you that don't know me, I have been involved in lighting for more than 25 years, involved in energy efficiency specifically for about the last 15. I have my lighting certification from NCQLP. Does anybody else in the room? I know I talked to at least one person on the break who had their LC. And I told him that it's my fault because I was also on the test committee for the test that he had to take. So if anybody's interested in taking that, I think it's a really valuable resource to be able to have that as part of your toolbox, to have your LC. And so with that, we're going to go ahead and start digging into this. So today, the objectives for the lighting presentation in conjunction with the programs is to talk about lighting and lighting controls technologies, describe some of the recent advances in all of that, provide you some of the best practices with lighting and lighting controls. Now, we're not going to dig into this too deeply. We understand, you know, that not everybody in the room is really involved in lighting technologies. If you want to get into more technical aspect of certain things that you hear today, you could certainly reach out to me later on, and we can certainly hook you up to certain things. We want to talk about how this all works with the New Jersey's Clean Energy Program incentive offering, and actually specifically talk about what products qualify for the Clean Energy Program, because that's always a big question. We're going to walk you through some of the application process. Brian's actually going to do a demonstration of some of the newer forms that have been brought into the program, and just plain how Clean Energy Program can help. So before we get into where things are going, where the advancements are, let's kind of review some of the common technologies that are already out there. So everybody know what linear fluorescent is? Looks like we still have some in the ceiling. You have T8, T5, T12. Does anybody know what the T stands for? Okay, so for those of you that aren't lighting geeks like me, all these letter designations like T5, A19, the T is the shape, so T is tubular, and it's usually fluorescent lamps. And then the number is the size of the lamp. And for some reason, in the lighting industry's infinite wisdom, years ago, they decided to do that in 1/8 of an inch. So now when you're looking at this, you can see a T8 is 8/8 of an inch or 1 inch in diameter. T5 is 5/8 of an inch. T12 is 1.5 inches. So linear fluorescent is common in most commercial and industrial applications, but generally sticks with interior. I have seen a few parking or car lots over the years that have actually had these big, huge fan fixtures that had linear fluorescent in them. Those have long since gone the wayside. We've moved to other technologies. High intensity discharge, which also can be high pressure sodium or pulse start metal halide. There's also still some regular metal halide still around. Those tend to fit commercial and industrial applications. They can be interior and exterior. They don't have too much difficulty dealing with extreme temperatures, whether that be high or low. Most of the HID sources can start and operate down to -20 degrees and can operate in some extremely high temperatures. So that's always one of the things that people look at when you're using them in industrial applications. Compact fluorescent lamps. Does anybody still have any compact fluorescent lamps? I see some around here today. They can actually be pin base or screw base, and they tend to work with mostly commercial applications. Again, temperature is an issue here, so that you really can't use the compact fluorescent lamps outside They really need to be in interior applications because they don't work very well in cold weather applications. So why am I talking to you about all of these? Because most of you are going to run into them, if you haven't already, when you're out working on your lighting projects in the field. But they all lead to the next step in the evolution, which is light emitting diode, if you didn't know what LED stood for. That's available in either lamps or fixtures. What I was explaining here a minute ago was just the light sources, the lamps. But the LEDs can actually be either in a complete fixture or it can actually be an actual lamp to replace existing lamps. Commercial or industrial applications, interior or exterior. Really cool thing about light emitting diodes is that they actually really kind of like cold weather. They do really well in low temperatures. The other interesting thing about that is how many of you have gone out there and said, oh, well, LEDs don't give off any heat. That's a misconception, folks. LEDs do give off heat. The variation is the fact that heat is demonstrated in watts. If you have a 32-watt lamp, it's going to give off 32 watts worth of heat. If you can use a lower wattage LED, 15 watts, it's going to give off only 15 watts worth of heat. So that's really, I've gotten into long discussions to debates with HVAC folks on, how that's affecting all the systems by lowering the wattage. Some people have said now you've got to increase the heating because you've reduced the lighting in this building so much because it was overlit. Now you actually have to pick up the heat from someplace. So we've gotten into all kinds of discussions about that. But LED does give off heat, and it needs to be dissipated properly. So we'll talk about that a little bit more. Interior or exterior applications works really well. So we're going to talk about fluorescent lamps for a moment and where the market is and what's been happening. You might have asked, all right, well, why is he talking about T12? Why did they put T12 back in the programs? The federal government outlawed them, didn't they? But the way that the rules have been written is there are loopholes that actually allow people to manufacture and sell T12 lamps. Here's the challenge, that most often they are less efficient than the previous T12 that you're removing. So if you had a 34-watt energy-efficient T12 lamp and you took it out and you tried to replace it with another T12 lamp, you probably have to buy a 40-watt unit to put it back in. And now you've increased the energy instead of reduced the energy. There's still millions of T12s in the marketplace. I know it's a little bit of an eye chart, but the green line on there shows you that from 100%, 100 units back in 2011, they're still selling T12 at about 35, 40% compared to 2011. So there's still quite a few of them that are actually going out into the marketplace to replace the existing lamps. And this is from the first quarter report that National Electrical Manufacturers Association, or NEMA, put out in June. So you can actually go to that particular website that's posted there and see the full report. So we need to get rid of the T12s. That's part of the reason we brought them, allowed them to get back into the programs. How's the market penetration? A few years ago, 2015 really is when what we call T-LEDs, using that T for tubular, a lot of the lamp manufacturers started building these tubular lamp replacements to replace all these linear fluorescents out there because there's a lot of them. And it's a very easy, low-hanging fruit replacement. So the T-LED started taking into the marketplace, but you can see as far as market share, that green band up along the top, there's still a lot of T12 out there. And then far and away, the T8 is kind of the ubiquitous fluorescent lamp these days. They're everywhere. And I don't know, Dean, do you know whether that's T8's up in the ceiling? I don't even know if you're here. You don't know. So now we're going to have to check. We have a whole bunch of people in the room that are willing to help you. Okay. So we've talked about what the sales are. The NEMA reports were talking about sales, what's actually selling in the marketplace, but that doesn't talk about what's installed. Most of these lamps have 25,000 hour lamp life. They can last, depending on the application, for 5, 6, 7 years. So there's still a lot of stock that's actually installed out there. This looks at the lamp stock across the entire breadth of lamp types of HID, fluorescent, compact fluorescent, halogen, and incandescent. You can see LED is starting to take over, but even as late as 2015, or as early as 2015, manufacturers such as Acuity Brands, everybody probably knows who they are, Osram, or the other name they go by, Sylvania, Philips, and Zumtobel. Zumtobel is a fixture manufacturer. They were reporting in 2015 that of new product sales, LED was 48 to 63% of their business. But at that same time, only 6% of the lamps that are installed, the linear tubular type fluorescent lamps, only 6% of them that are actually installed in the marketplace were actually LED. All the rest were fluorescent. So there's a long way to go. So an organization by the name of IHS put together a study and that forecasts that in 2022, it's not that far away, 5 years, they're still forecasting less than 40% worldwide is actually going to be converted to LED. And one of the other organizations, Strategies Unlimited, did another study that determined that in North America, the forecast is closer to 50%. So we're doing a little bit better job than worldwide, but we're certainly not where we need to be. We need to try and get rid of some of these older technologies to be able to improve energy efficiency. Okay, switch gears to controls. Everybody's putting controls in their projects, right? So one of the things that we looked into is of all the various different segregated applications under Smart Start buildings, about 80 to 90% of them are lighting applications. So we kind of looked at that by itself. 80 to 90% of them are lighting only, and the remainder are controls. So there's not an awful lot of controls, relatively speaking, actually being put in or being submitted through the various different programs. So here's a great opportunity for people to be able to go ahead and keep working on controls, promoting controls, and they can do a great job to help save energy. The cost payback is pretty quickly. Let's look at some of the technologies that are out there. Most of these technologies have been around quite a while. Occupancy sensors, vacancy sensors, what's the difference? Occupancy sensors generally will go on automatically when you walk in the room, and then they'll turn off automatically. Vacancy sensors, you have to manually turn the switch on. We all know how to turn on a light switch. Since we were old enough to reach up and touch the light switch, we all know how to turn a light switch off. What we can't ever remember to do, anybody got kids at home, can't ever remember to turn the lights off. So that's what the vacancy sensors do. Occupancy sensors are available in passive infrared, ultrasonic, microphonic. We didn't want to dig down into the real nitty-gritty of those technologies today. But if you have questions on any of these that you see, certainly reach out to me. But most of you are probably really familiar with passive infrared, which basically just reads the heat motion in the space, registers that, and then keeps the lights on because something's moving there. Ultrasonic's actually sending a signal out into the space and bouncing it off of the various different surfaces, and it acknowledges when there's something new in the space that should not be there if they want to turn the lights off, so it keeps the lights on. Microphonic's an interesting technology, and it's actually a pretty small segment as far as I know, and if anybody knows differently, let me know. But as far as I know, there's only one manufacturer out there that's actually doing what they call microphonic, and it's essentially the device actually has a small microphone in it that notices sound. So they usually use that in combination with passive infrared. Somebody can come in the space, passive infrared will turn the lights on because they passed the actual device and saw the heat motion. But then if there's partitions or things in the way, microphonic will hear sound from the space and keep the lights on. So dual technology can either be passive infrared and microphonic or passive infrared and ultrasonic.